questions 5 through 7 of the 2001 grade 12 Euclid math contest. Determine all integer values of x such that x squared minus 3 multiplied by x squared plus 5 is less than 0. So we have a situation where you have x squared minus 3 and x squared plus 5 is less than 0. So if we have two integer entities, because they're integers, right? The question tells you that. And you multiply them together, how do you get a value less than 0? We want the product to be negative. Well, does positive give you negative? No. How about positive negative? That does. How about negative positive? That does. A negative would give you a positive. So we have to only look at these scenarios here. Either this is positive and this is negative, or this is negative and that's positive. All right? Now, in the first scenario, one thing I noticed is that x squared, x is an integer, if you square it, it will be positive. If you square any number, it will be positive. So then if you add 5 to it, it will be positive again. So this can never be negative. So this is out. So the only scenario is this one right here, where x squared minus 3 is negative and x squared plus 5 is positive. So let's go with that. X squared minus 3 is less than 0 and x squared plus 5 is greater than 0, like that. Now, if we look over here, x squared plus 5 is greater than 0, x squared is greater than negative 5. But if we take the square root of both sides, we're going to get the square of a negative number, and we want integer values. So this is not going to lead to anything. So we are really just left with one possibility. And this we can solve. X squared is less than 3. So x is going to be in the boundaries of positive root 3 and negative root 3, like that. So if you have a number line and you've got negative root 3 here and positive root 3 here, and root 3 is approximately 1.73 and negative root 3 is obviously negative 1.73. What are the integers in between those boundaries? Well, negative 1, 1, and I think that's it, and 0. Just 3 integers. So x can be either negative 1, 0, or 1. So that satisfies our question. At present, the sum of the ages of a husband and wife, P, is 6 times the sum of the ages of their children. 2 years ago, the sum of the ages of the husband and wife was 10 times the sum of the ages of the children. 6 years from now, it will be 3 times the sum of the ages of the children. Determine the number of children. So we have got 2 scenarios, or 3 scenarios. The first one is in the present. We have the ages of the husband and wife is 6 times the sum of the ages of the children. Now we don't know how many children there are. That's what we have to figure out. So I'll write kid 1 plus kid 2 plus kid 3 all the way till kid n, because I don't know how many kids there are. So that's the first one, and they actually are saying that the ages of the husband and wife is given a letter, P. H plus W is P. And the ages of the children is abbreviated C. So they're combining all of these into C. Okay, so that's the first one. 2 years ago is the next scenario. So 2 years ago, the husband would be H minus 2 in terms of his age, and the wife would be also W minus 2. And each of these, Each of these kids are also going to be minus 2 in terms of their age. So K1 minus 2, K2 minus 2, dot, 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 all the way till Kn minus 2. And they're saying 2 years ago, the sum of the ages of a husband and wife was 10 times the sum of the ages of the kids. So you got 10 there. So this becomes H plus W minus 4 is equal to 10. We've got the sum is K1, K2, so that's in there, so there will be a C in there. But then we have to account for all these minus 2's, and there's n of them. So n times 2, like that. Okay? And H plus W is P, so P minus 4 is equal to 10 times C minus 2n. This is our second scenario. Our third scenario is 6 years from now. It will be 3 times the sum of the ages of the children. Okay, so that means H plus 6 and W plus 6. And this is going to be 3 times the sum of the ages. So each of these is now K plus 6, K1 plus 6, K2 plus 6, all the way dot, 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 until Kn plus 6, like that. So again, we have H plus W plus 12 is equal to 3 times, all the K's add up to C, just like they did up top. And then now we have to account for all these 6's, and there's n of them. So 6n, like that. So this H plus W is P. P plus 12 is equal to 3. C plus 6n. All right, so we have equations. We have this one. We have this one, entirely based on what they gave you in the question stem. I haven't calculated anything yet. So this is what we have to work with. So I'll call this 1, I'll call this 2, and I'll call this one 3. So from the first one, P is equal to 6C. Well, that's very helpful. We can somehow get rid of one of these. So there's many ways of doing this. Probably just 2 minus 1 would be a quick way of eliminating at least the P. So 2 minus 1, we'd have P minus 4 minus P. And then on the left side, or right side rather, we'd have 10C minus 2N minus 6C. Correct? Unless I've done something wrong. So the P's cancel. This gives you negative 4 is 10C minus 20N minus 6C. So we have 10C minus 6C is 4C minus 20N minus 4. And that's about as far as we can go. We can isolate for C and then probably substitute it into the next one. So isolating for C, we'd get 20N minus 4 over 4 is C. Okay, and now let's work with 2 and 3. So let's do 3 minus 2. That should help us. So we have P plus 12 minus P plus 4, because you're subtracting. And this gives you 3C plus 6N minus 10C minus 2N, like that. And this gives you 16. And this looks like 3C plus 18N minus 10C plus 20N. And anything? Nope. No numbers other than the 16. We've got 38N, and we have 7C, minus 7C. All right, we can substitute this now, and we'll have it all in N. Then we can calculate N. So minus 7C is 20N minus 4, all over 4. So this becomes 16 is equal to 38N minus 140n minus 28 over 4, like that. 16 is equal to 38n minus 35n. And this becomes plus 7, right? Because you got two minuses, minus, minus. So bring the 7 over and you get 9, and you get 3n, and therefore n is equal to 3. So there's only 3 kids. I thought there was more than that, but that's okay. What is, the number of children. So the number of children is 3. Four teams, A, B, C, and D, competed in a field hockey tournament. 3 coaches predicted who won the gold, silver, and bronze. Coach 1 predicted as follows, Coach 2 predicted, and Coach 3 predicted. Each coach predicted exactly one medal winner correctly. Complete the table in the answer booklet to show which team won which medal. So the key to this question is what I underlined. And this is really just a trial and error type of question. So let's work with this. So let's say Coach 1 accurately predicted that the gold medal was won by Team A. So gold for A. If that is the case, the other 2 coaches have to be wrong for their gold medal prediction because each coach predicted only one winner correctly. Okay? So Coach 1 predicts gold is for A, so he's wrong about the silver and he's wrong about the bronze. All right? So let's go to Coach 2. Coach 2, he has to be wrong about gold because gold is for A. Gold can't be for B. And how about silver for C, bronze for D? Well, let's say Coach 2 says that silver for C. That's his accurate prediction. Okay? So that's his right one. Now, he can't be right about the bronze one because he can only be right about one. Now, let's turn our attention to Coach 3. Coach 3 has gold for C. Well, gold can't be for C because gold is for A. So that's wrong. He has silver for A. Well, silver is for C, so that's wrong. And he has bronze for D. Can D get the bronze? Bronze for D. Well, it seems like, okay, that's a possibility. But if he was right that bronze is for D, then that means Coach 2 is right also for bronze equals D. See what happened there? And therefore, Coach 2 would be right for 2 predictions, and that goes against the rules of the question. So despite all of our efforts, that scenario doesn't work. That's okay. We just keep trying and see if we can find something that does work. All right, let's try another scenario. Coach 1. Let's say Coach 1 says, let's try the other way, starting from the other end, that bronze goes to C. Okay? So he's right about that, so he has to be wrong about the other 2, right? Because he can only be right about one medal prediction. Now let's turn our attention to Coach 2. Bronze goes for C, right? We are saying that is the accurate choice. So bronze cannot be for D because it can't be because it's gone to C. Now, let's say his silver correct. He has correct either silver or gold in terms of his prediction. Well, we chose silver for C for Coach 2 up there, so that didn't result in much. So I'm going to go for gold for B as his accurate prediction. Gold for B. Okay, so that's an accurate prediction. Now he can only be right once, so silver cannot be for C. Now let's turn our attention to Coach 3. We've already got the prediction accurate for bronze and gold, so silver is the only thing that left us with, and therefore silver must go to A. Silver for A. Now let's see if there are any discrepancies here. If bronze is for C, coach 1, he is wrong about the other 2. Okay? And is he wrong about the other 2 in the way that we chose? Silver went for B. Yes, he's wrong about that. Gold went for A. Yes, he's wrong about that. Okay. Now let's turn our attention to coach 2. We're looking for discrepancies here. We said that he accurately predicted gold for B, right? So he must be wrong about the other 2. Silver for C, is that wrong? Yes, it is. Bronze for D, is that wrong? Well, D is not in our metal table here. We only have metals for A, B, and C, so we don't know yet. All right, let's turn our attention to coach 3. He accurately predicted silver for A. So what about gold for C? Is that incorrect? Gold for C. Yes, because gold is for B. So that is incorrect. How about bronze for D? Well, we are pretty much giving bronze to C. So it doesn't matter if it's not in the metal table. Bronze cannot go to D. So you see how it's working there? It's really just a lot of trial and error and kind of convincing yourself that everything works out. So despite all this gobbledygook, we did invent a non-traditional or non-scientific method of coming up with the right answer. And indeed, this table is this scenario. So gold goes to team B, silver goes to team A, and the bronze goes to team C. Okay, that is the scenario that satisfies the condition in the question that only one prediction per coach is correct. In triangle ABC, AB is equal to BC is equal to 25 and AC is equal to 30. The circle with diameter BC intersects AB at X and AC at Y. Determine the length of XY. Okay, so the first thing I want to do is just fiddle around with the angles here. So I drew it pretty big because I'm going to have to put in a lot of angles. So BC is the diameter of the circle. Okay, so let's draw a center point. So approximately here. And let's draw a few lines to connect some dots together. So I'm going to draw a line there to connect the center to X and one more to connect the center to Y. All right, and I'm going to start just filling in some angles. And it's not that hard to do that because they've given us some pretty good clues. They've given us that AB and BC are both equal to 25. So that means if AB is equal to BC, this is an isosceles triangle. And therefore, these two angles are the same. If this is M, this is also M. Okay? And I hope you notice that if this is the center of the circle, the one that I drew in red, then all the lines going out from C to the boundary of the circle are radii. So, for example, this is a radius and this is a radius. And if that is the case, then that becomes an isosceles triangle also. So therefore, this is M. Right? If that angle is M, that angle is M. And you can do this all over. So, for example, this is also a radii, and this is also a radius. And therefore, if this is angle N, that's angle N. All right? So you just fill this in, 180 minus 2m, because the sum of the angles of a triangle are always 180, as I'm sure you know. This angle in here, 180 minus 2n, right? And then we continue our labeling. If this angle is m and that is m, then that means that angle B, right here, is 180 minus 2m. And notice this is a radius, so that's an isosceles triangle. So therefore this is also 180 minus 2m. And then we just need this one. Well, the sum of the angles of a triangle are 180, so that means 180 is equal to 180 minus 2m plus 180 minus 2m plus, we'll call it whatever, z. So that means that z will be, let's see, we bring the z over, we get 4m minus 180, like that. So right there, 4m minus 180. So that's a pretty straightforward way of labeling everything. Now, all the angles about a line are 180, like that. So all of those angles together would equal 180. So we got 4m minus 180 plus 180 minus 2n plus 180 minus 2m. All of this is 180. So we got a whole bunch of 180s. Those cancel. These cancel. So we get 2m minus 2n is equal to 0. And therefore 2m is equal to 2n. And therefore m is equal to n. So there you go. We got a lot of our relationships in terms of the angles. Now we can move forward with something called the Law of Cosines. And the Law of Cosines, just in case you're not familiar with it, if you have a triangle, if you have, let's say, ABC, like that, and these side lengths are C, A, and B, C squared, this C, is equal to A squared plus B squared. Looks a lot like the Pythagorean theorem, but this is not a right triangle, so we have to incorporate the angle minus 2AB cos of C, the angle. So that's the law of cosines, and we have to implement that on this shape. And if you remember, if you label this, this was 25, this whole thing, AB right there. This BC was also 25, and AC was 30 right there. So we are going to do the law of cosines on the entire triangle like that. And the angle that we're going to focus on is this one right here. So we've got 25 squared, this guy right here, is equal to 25 squared here, plus 30 squared, right there, minus 2 times 25 times 30 cos of m, because we have an angle m. So these 25s cancel, and we can now bring all this over to the other side. 2 times 25, 30 cos m is equal to 30 squared. One of these 30s will go, so that will be just 50 cos m, and therefore cos m is equal to 3 over 5. And if you get out your calculator, m will be approximately 53.1 degrees. All right, so we now have one final step remaining to figure out xy. And what is xy? Xy is the length from here to here, or in our big diagram, from there to there. Now, which triangle are we going to figure out xy with? Well, it's this one right here. This triangle right here. Okay? That triangle we will use. And just to avoid confusion, I will draw it out over here. So we can quickly draw that so we can label it without getting too confusing in terms of our diagram up there. So we had the center is C, right? That is X. And this is Y. And this is N, but N we know is equal to m, so we can just put m in there. All right, and then this angle in here was 180 minus 2n, but m is equal to n, so we can just put 180 minus 2m. The reason we want to stick with m is because m we figured out right there. And we need side lengths. So how do we figure out side lengths? Well, if you recall, BC is the diameter of the circle. And the BC is 25, so the radius from there to there, is 12.5. Okay, it's just half of the diameter. So if you draw a line from C to Y, that's the radius. And so is a line from C to X. So therefore, these lengths are 12.5 and 12.5. All right, so we have everything we need to figure out xy using the law of cosines once again. So xy squared is equal to 12.5 squared plus 12.5 squared minus 2 times 12.5 times 12.5 cos 180 minus 2m. So we will now try to expand this. 156.25 plus 156.25 minus 312.5, and then cos m is 53.13. So I'm going to figure out cos of 180 minus 2m. 180 minus 2m is calculated to be about 73.7397. Trying to get this as accurate as possible. So we have xy squared is equal to 312.5 minus 312.5 times the cos of that, which is 0.28, and then xy squared is equal to 312.5 times 0.28 times 312.5, which is 87.5. And therefore this becomes 225. And therefore, if you take the square root of 225, you will get 15. So there you go. xy is equal to 15, which is what they wanted at the beginning of the question, right there. Determine the length of xy. What is the value of x such that this expression is equal to 2? Okay, so let's see what we have. We have log 2 is the base. Then we have in brackets log 2 is against the base 2x minus 2, all equal to 2. So based on the rules of logs, 2 to the power of 2 is equal to log of 2x minus 2, all to the base 2 like that. So this becomes 4 is equal to the log of 2x minus 2 to the base 2. And therefore 2 to the power of 4 is equal to 2x minus 2. Okay, so that's how you solve that. And then 2 to the power of 4 is 16. 2x minus 2. Bring the 2 over, you get 18 is 2x. And therefore x is equal to 9. So that's part A. Part B. F at x is equal to 2kx plus 9, where k is a real number. If f at 3 over f at 6, the ratio is 1 to 3, determine the value of f at 9 minus f at 3. All right. So they've got this function 2kx plus 9, where k is a real number. And they're saying that the ratio of f at 3 to f at 6 is 1 over 3. And they want you to find f at 9 minus f at 3. All right? So first let's deal with this one here. f at 3 would be, according to this, 2, 3k, 2 to the power of 3k, plus 9. And then f at 6 would be 2 to the power of 6k, plus 9. And they're saying that that is equal to 1 over 3. Now, at this point in the question, instead of having to deal with these types of numbers, I'm going to make it a little easy by substituting some values. I'll let 2 to the power of 3k equal a. And therefore, this is essentially 2 to the power of 3k all squared, and that becomes a squared, right? Because 2 to the power of 3k all squared would be 3k times 2, which is 6k. Like that. And that will make it just a little bit easier, I think, to digest. So substituting that, we'll get a plus 9 over a squared plus 9 is equal to 1 over 3. And then across multiply, you get 3a plus 27 is equal to a squared plus 9, right? And then put everything on one side, a squared minus 3a minus 18 is equal to 0. And I think this factors a 6, 3 minus plus, like that. So a is either equal to 6 or minus 3. Well, a is 2 to the power of something, so a cannot be negative. So the only solution for a is 6. That's the only value of a that actually makes sense. All right, now they want you to find f at 9 minus f at 3. Okay, let's do that over here. F at 9 minus f at 3. Okay, f at 9, according to this formula right here, would be 2 to the power of 9x, or 9k rather, plus 9. And f at 3 would be 2 to the power of 3k plus 9, like that. So this looks like 2 to the power of 9k minus 2 to the power of 3k, because the 9's cancel, 9 minus 9. Well, we had over here some good relationships. 2 to the power of 3k was a, right? And 2 to the power of 9k is essentially 2 to the power of 3k all to the power of 3, right? Because you would have to multiply 3k by 3, so it would become 2 to the power of 9k. So if 2 to the power of 9k is indeed 2 to the power of 3k to the third, then we can substitute a for 2 to the power of 3k. So it becomes a cubed, like that. You see how it's a little bit easier to digest. And then a we figured out was 6 right here. So this becomes 6 to the power of 3 minus 6. 6 to the power of 3 is 216 minus 6, and therefore this is equal to 210. Our value for f at 9 minus f at 3.